Have you ever wanted to build a network's defenses right from scratch? Well, today, that's exactly what we're going to do. We're going to build a digital fortress piece by piece using a Palo Alto Firewall. And by the time we're done, you'll have a super clear step-by-step guide to get your own firewall configured and your network locked down. So let's jump right in.
So here's our game plan. First, we'll look at the blueprint to get what we're working with. Then we'll lay the foundation with the initial setup. After that, it's all about drawing the map of our network with zones, setting the rules with policies, arming the guards with some really cool next-gen features, and finally, climbing the watchtower to see what's happening.
Okay, first things first, the blueprint. Before you can build anything solid, you gotta understand your materials. So, what in the world is a next-generation firewall anyway?
And that's a fantastic question, right? Because you hear that term, next generation, thrown around all the time. But what's the real difference? What separates it from a traditional firewall?
This really breaks it down. Think of it traditional firewall like a bouncer who only checks your ID, that's your IP address, and which door you're using, which is the port. Pretty basic. A Palo Alto firewall, though, it's like a bouncer with superpowers. It doesn't just check your ID, it knows exactly who you are as a user and what app you're trying to use. Is it Slack or is it something malicious? It does this with deep packet inspection, literally looking inside the data to stop threats before they even happen. It's a whole different ballgame.
All right, with our blueprint understood, it is time to break ground. We are now laying the foundation. This is all about getting that very first connection to the firewall and getting it ready to be managed.
And that first step is super simple. You just take an Ethernet cable and plug your computer directly into the special management port on the firewall. Straight out of the box, it's sitting there waiting for you at the IP address 192.168.1.1.
So, once you're plugged in, just pop open a web browser and go to that IP address. You'll log in with the classic default credentials, admin for the username and admin for the password. Now, the very first thing it's going to make you do, and this is non-negotiable, is change that password. Good. After that, you'll just put in some basic network info, like its IP address, DNS servers, and gateway. That way, you can manage it from anywhere on your network, not just when you're plugged into it.
Okay, we've got secure access. Now we need to define the different territories inside and outside our fortress. This next phase is all about drawing the map, where we create these logical areas we call zones.
The idea here is actually really simple. We take each physical port on the firewall and assign it to a zone. For example, as you see here, the port that's connected to the internet, that goes in the untrust zone. Makes sense, right? The port for your internal office network, your LAN, that goes in the trust zone. And if you have servers that need to be accessible from the internet, you might stick them in their own special zone called a DMZ. This map is how we start to organize everything.
Now, I can't stress this enough. Zones are the absolute foundation for every single security rule you're going to create. You literally can't do anything without them. Every active interface has to be in a zone, period. Just think of them as the clearly defined regions on our map. Inside the walls, outside the walls, and maybe a courtyard in between.
With our map all drawn out, it's time to decide who gets to go where and what they're allowed to do when they get there. We are now setting the rules. This is where we create the security policies that are the real brains of the operation.
So what is a security policy? Well, at its core, it's just a simple instruction for the firewall. When any kind of data tries to move from one of our zones to another, say from your safe trust zone out to the wild west of the untrust internet, a policy has to be there to say, yep, you're good to go, or nope, you're not allowed.
Let's build a super common rule, one that lets our users get to the internet. The first piece of the puzzle is defining the path. We just tell the firewall, hey, I'm making a rule for traffic that starts in the trust zone and is trying to get to the untrust zone. Simple as that.
Next up, we have to define what kind of traffic this rule is for. Now, for a basic let everyone get online rule, we can start by setting the source, the destination, the application, and the service all to any. This basically means we don't care who on the inside is going where on the outside or what app they're using. We can get way more specific later, but this is the perfect starting point.
And finally, the most important part, the action. We set this one to allow. So let's put it all together. Any traffic from trust to untrust is now officially permitted. And boom, just like that, we've created our first real rule.
Now listen up, because this is a pro tip that you absolutely have to remember. The firewall reads your list of policies from the top down, one by one.
And the second it finds a rule that matches the traffic it's looking at, it stops. It applies that rule and doesn't look any further. What does that mean? It means the order of your rules is everything. You always want your most specific rules at the very top and your general catch-all rules at the bottom.
There's actually one more little rule we need. See, all of our computers on the inside use private IP addresses that aren't allowed on the public internet. This is where something called Network Address Translation, or NAT, saves the day. It's like having a master translator at the fortress gate. It lets all of your internal people speak to the outside world using one single public identity.
So we create a quick NAT policy. And all this rule does is tell the firewall, hey, when you see traffic coming from my internal trust zone, just swap out its private source IP address with the public IP address of your untrust interface. If you don't do this, the internet has no idea how to send a reply back to you. It's totally essential.
Okay, this is where things get really cool. Our fortress has walls, it has a map, and it has rules for traffic. But right now it's a pretty passive defense. It's time for the best part, arming the guards. This is where we turn on those true next-generation security features.
And we do this by attaching what are called security profiles right onto that allow rule we just made. Think of these like highly trained specialist guards. We can turn on antivirus to scan files, anti-spyware to spot malicious callbacks, vulnerability protection to stop exploits in their tracks, URL filtering to block sketchy websites, and even file blocking to stop people from downloading dangerous file types. This right here is what makes it a real threat prevention machine.
So our fortress is built, the rules are in place, and the guards are on duty. The final stage is to build the watchtower. We have to make sure everything's working as expected and learn how to actually watch the traffic coming and going.
And testing is pretty straightforward. Just hop on a computer that's inside your trust zone and try to ping something on the internet, like Google's DNS server at 8.8.8.8. If you get a reply, congratulations, you have internet. Then you can dive into the firewall's Monitor tab. The traffic logs will show you that successful ping hitting the policy you created, and even better, the threat logs will show you if any of your newly armed guards have already caught something bad.
And there you have it. We went from an empty box to a fully functional digital fortress. The foundation's been laid, the rules have been written, and the watchtower is officially manned. So the only question left is, with all this power at your fingertips, what kind of attack are you going to defend against first?